All right, I'm not quite sure how most people are going to want to think about this question. As I've been doing, I will show you both a kind of calculator way and a more algebra way. The calculator way requires some thought. You need to understand what's going on here. So first of all, we could do the easy thing, which is graph this line, y equals, or this quadratic, y equals negative 2x squared plus 9x, and see what it looks like, right? So it's an upside down parabola. Now, we can't really graph the other thing, right? 2y equals c, because we don't know what c is. C is a number, and we're trying to find that number. Now, if we had answer choices, this would be actually really easy to guess and check. Just 2y equals choice A, 2y equals choice B, and just graph them and see when it kind of crosses and forms only one intersection point. We don't have that ability, and unfortunately, the right answer is such a weird number that we would never guess it kind of naturally. So we're going to need to understand what's happening here. But what 2y equals c is it's a line, but it's specifically a perfectly horizontal line, right? It goes directly left to right. There's no up and down movement, and we can see that because there's no x. C is not x here. C is a number, so we kind of have something like y equals a number. And that means that if we're trying to get it to intersect our parabola at exactly one spot, it's got to hit the top. That vertex is the main point. So we can tap it, and we're going to get the coordinates of the vertex. So they look messy. We can write them down anyway. We get 2.25, 10.125. So, well, what does that mean? Basically, we're getting an x and a y, and our equation that we need to care about only wants a y. So we would just take the 10.125 and substitute that in for the y, and so we would get 2 times 10.125 is equal to c. Do that in your calculator. 10.125, you might be able to do that in your head, is 20.25, which is c, so there is our answer. Now, if you want, I'll just graph that, right? 2y equals 20.25, and we can see it now, right? Look at that spot. Oof, I hate the zoom on this thing. We can see that it's just touching it once. It's just hitting the top and moving on. It's not passing through like if I made it something smaller, like 20, right? We can see now it's hitting it twice, right? So that's kind of what we found. But I understand that's very theoretical. We need to understand a lot of things that aren't explicitly told to us. It can be hard, but the calculator does let us see this without doing a whole lot of work. We just need to understand what we're entering in the calculator. But I want to show you the algebra way. Maybe for some of you, the algebra is more understandable. It's at the very least, it's very repeatable. When we have a quadratic, a parabola, and we're trying to understand the number of solutions, we're going to need to think of an idea that's known as the discriminant. And it's part of the quadratic formula, specifically b squared minus 4ac, the part under the radical. So without going through the whole quadratic formula, we can use this piece of it to know the number of solutions, the number of intersections, the number of x-intercepts, without having to do all the work of finding out what those x-intercepts are. So it's helpful here because they don't want to know specific, they don't want to know too much about the specific points. They just want to know kind of what happens when there's one. So we're going to need to merge these two equations together to be able to do this. So what I would do here is since y is equal to this weird thing, I would do a little substitution. And I would say, actually, let's do this down here. I would do 2 times negative 2x squared plus 9x, right? I'm substituting in for y is equal to c. Then I would distribute negative 4x squared plus 18x is equal to c. Then I'd move everything over to get it into a real quadratic. So 0 is equal to 4x squared minus 18x plus c. And now I can use the discriminant because I have values of a, b, and c, and just coincidentally, c is the c that I need to find. And when I know that there is only one point of intersection, I know that b squared minus 4ac is going to equal 0. This is just a thing to memorize. So if I've already lost you, then, you know, I get why you might want to do the calculator method. But this will come up in ways that we kind of need to know this. So b squared minus 4ac is equal to 0 when we have one solution. So now we have all these values for a, b, and c that we can plug in. So b is negative 18. So negative 18 squared minus 4. A is 4. C is just c, so I'll leave it as a variable. And you can see now that when we plug that in, we have the ability to solve for c because it's just its own little variable. So negative 18 squared is 324 minus 16c is 0. So I would subtract 324, I'd get negative 16c is equal to negative 324. I would divide by negative 16, and I would get that c is 20.25, what we got before. Yeah. Is that better? Probably not. But like I said, especially if you end up doing well on this section and you get into Module 2, which has the harder math questions, this idea of the discriminant is going to come up. So the only things I didn't talk about are the other situations. This is when we have one solution. If we had two solutions, the discriminant would be greater than 0. And if we had no solutions, this is only for quadratics, the discriminant would be less than 0. So that 0 is our key kind of marker. And there are reasons for that. You can watch my old videos to kind of understand why, but it's another way of doing it. It's error prone, it's kind of confusing, but for some of you, maybe that makes more sense than the graphing. I don't really know. But I am thankful that we have this new calculator built in so that we at least have the option of kind of finding the answer in some backwards way if we don't really understand the algebra.